Alright guys, this video is the first video of chapter 4. So all of chapter 4 is about transformation. So a lot of you did this in middle school, so hopefully this will be a little bit easier for you. For those of you who are visual learners, you'll probably like this chapter quite a bit. So if you recall from middle school, transformations can come in many forms. And these words may or may not sound familiar to you, which is fine. We have translations, we have rotations, we have reflections, we have dilations. So if any of those words sound familiar, you've done this before. Okay, if they don't, that's okay, because we'll go through it all. But first, let's define transformation. So you should be looking at the sheet that looks like this. Okay, so let me get my pen here on this tablet. All right, so a transformation is an operation that transforms a figure. Okay, so think of like you're changing it in some way. It's what it means by transform. The figure is the image, so when you're done transforming it, we call that the image, and the original figure is the pre-image. Okay, so the pre-image always comes before the image. All right, so a mapping is a correspondence between sets of points so that each point in the first set corresponds to exactly one point in the second set. So if you think back to algebra, this is called a function. Okay, an isometry is a rigid transformation that maps every figure onto a congruent figure so that the pre-image and the image are congruent figures. A transformation in the plane is an isometry if it preserves length, angle measures, parallel lines, in betweenness of points. Okay, so if I go back to up here, an isometry and a rigid motion or rigid transformation, these are the same things. Okay, so I'm going to write in here an isometry, and I believe your book calls them rigid motions, are the same thing. And all those two words mean is you transform something and you get a congruent figure out of it. All right, so translation is just one of the many transformations we're going to talk about in this chapter. So a translation moves every point of a figure the same distance and in the same direction. Okay, I'm going to put in here translations are isometries / rigid motions. So what that means is that anytime you translate a figure, you're going to get a congruent figure out of it. Okay, all we're doing is moving the points. So translations in the coordinate plane can be described by the mapping notation. So this is how we write it in math form. So it'd say x comma y goes to parentheses x plus a, y plus b. Okay, so if we think of our x coordinate, this is our, if we have a coordinate axis, it tells us how far left and how far right to go. So our x plus a tells us if we move left or right. Okay, now on a coordinate plane, our y-axis is up or down, so it tells us how far up or down we're moving, and so therefore our y plus b tells us how far up or down we're going. Okay, so if we're going left, this plus here will be a negative, and if we're going right, this plus here will be a plus. Okay, and then if we're going up, so plus b would be a positive, but if it was y minus a number, we would be going down. And it'll make more sense after we do some examples. All right. So the pre-image of a translation is the original figure. So I'm going to put original. If you don't like the word original, you can put the starting figure. It's the figure that we start out with prior to the transformation. Okay. So here's an example. Now, one of my absolute pet peeves is when we have a graph and we don't label the points. So A is the negative 4, 1, B is the negative 2, 4, C is the 1, 2, and D is here. Okay, so when we translate something, or anytime we make a transformation, our A is going to go, we call it an A prime. Our B is going to go to a B prime. And how we see that is by this little, it looks like an apostrophe. So we would say this as A prime. Okay, and this, because of this apostrophe, would say this is D prime. And basically that's telling us that this new point is the mapping of the original point. All right, so this is our rule here. Okay, so xy goes to x plus 3, y minus 6. So this x plus 3 tells us that we are going to add 3 to every x coordinate. Okay, so remember the first coordinates are our x coordinates, right? So negative 4 plus 3 would be a negative 1. Negative 2 plus 3 would be a positive 1. 1 plus 3 is a 4. And negative 2 plus 3 is a positive 1. Okay, now the y minus 6 tells us that we are going to subtract 6 from every y coordinate. Okay, so once again, our y coordinates listed second. Okay, so 1 minus 6 would be a negative 5. 4 minus 6 would be a negative 2. 2 minus 6 is a negative 4. And negative 3 minus 6 is a negative 9. All right, so what we have here, guys, these are the new coordinates of our figure. So this would be our pre-image. And then after we graph these, this would be the coordinates of our image. Okay, so go ahead, take the time, graph these on this graph. Make sure you label points A prime, B prime, C prime, and D prime. All right, so after you graph it, you should get something that looks like this. And what you notice is we have two congruent figures, okay? And remember, if we go back to this rule right here, and we said this x plus 3 tells us we're moving right 3. And the x minus 6 says we're moving down 6. If we count from like A, if we go right 1, 2, 3, down 1, 2, 3, 4, 5, 6, we would be right here at A prime. Okay. From B, if we went right 1, 2, 3, and down 1, 2, 3, 4, 5, 6, would be right here at B prime. Okay, so the same thing is true for C prime, same thing is true for D prime. So all we did is we shifted this pre-image here to the right 3 and down 6. All right, before we even start here, for both of these, I want to label the points. So let's just be consistent. Label this point A, this point can be B, this point can be C, and then let's do, I don't know, D, E, and F. Okay, now we're going to write the coordinates of those points. So the coordinates of A here, the coordinates of B here, the coordinates of C here, D, E, and F. All right, so after you have those labels, let's go ahead and write in the coordinates. So like A is at negative 1, 2, 3, 4. So A is at negative 4, and then it's up 1, 2, 3, 4. So negative 4, 4. B is, my X value is 0, and I'm up 1, 2, 3. So 0, 3. So go ahead and do that for C, D, E, or F now. All right, so we're going to go ahead and do this one on the left together. So we're going to translate it using this rule. Okay, so if you first remember, I'm going to subtract 1 from every X coordinate. Okay, so -4 minus 1 is -5. 0 minus 1, -1. -1 minus 1 is -2. Okay, then I'm going to add 3 to every Y coordinate. So 4 plus 3 is 7, 3 plus 3 is 6, and -4 plus 3 is -1. All right, so now we have the new coordinates. So this would be my A prime, my B prime, and C prime. So go ahead and plot these points on this graph and make sure to label your A prime, your B prime, and your C prime. All right, so after you plot them, this is what you get. And remember to label each point, A prime, B prime, and C prime. If I were to have a quiz or something and you didn't name these points, you would get some points taken off. All right, now I want you to go and do this second one on your own. So right here is our rule, okay? And I want you to go ahead and change these points, write the new coordinates. So this will be my D prime, my E prime, and my F prime, and then plot them when you're done with that, and then we'll go over it. All right, so double check what you have against mine. This X, think of it as like X is the same thing as saying X plus 0. So our X coordinate shouldn't have moved. Okay, and then the Y coordinate, we're going to add 3 to it. And if we check our graph, all we did, remember this first one here tells us how much left and right we go. So we went 0 left or right. So we didn't change, we didn't move left or right. And this Y plus 3 meant we move up 3. So as you can see, from every D to D prime, E to E prime, F to F prime, all we did is moved up 3. All right, let's do this example at the bottom of the page now. Now before I really start in heavy, I'm going to go and I'm going to label all these coordinates. So 1, 2, 1, 2. So this is like 2, 2. This is 0, 0. So go ahead and do that for all of these coordinates. All right, guys, so now that I've put the coordinates, and you should have 2, first of all, this should be a -2, not a 2, like I said. Now we're going to find the rule that takes point Z to point Y. So here's my Z, here's my Y. So I'm going to compare my X coordinates first. Okay, so my rule says X, Y goes to, now I'm going from a -2 to a -4. So I'm subtracting 2 from my X coordinate, so X minus 2. And my Y, I'm starting at a 2 and I'm going to a -2. So 2 minus 4 is -2, so it'd be a Y minus 4. Okay, so I'm going to do the same thing from Y. I'm going to start at Y, which is here, and I'm going to go to W, which is here. Okay, so I always start the same, X comma Y goes to, well, my X coordinate, I'm going from a -4 to a 0. So I would have to add 4. So it'd be X plus 4, comma, my Y coordinate, I'm going from a -2 to a -4. So I'm subtracting 2 from my Y coordinate, so Y minus 2. Okay, go ahead and do these last 3 on your own, and then we'll go over them. All right, so these are what you should have gotten. So go ahead and double check what you got. All right, now to end this video, what is an isometry? It is when we, so when every point of the pre-image is mapped to the image so that the pre-image is congruent to the image.